Yeah. I mean, to be fair, you did like. Like I said, something. Yeah, those mainly. Are they not? I mean, like it might be. Okay. That's tomorrow. That's Friday.
Okay, let's start off by, let me just, review the calendar here. So today we're gonna start our test review. And gonna show the main topics that we're going to focus on. If you guys go to the back of your packet that you just picked up, these are your test topics. Particle motion problem. We can remove this. Okay. If I have it on the test, it'll be a bonus, but I'm not going to spend time going over. This is really just setting velocity equal to 0, find what is particle change direction, things like that, involving Trig, but I'm going to just focus on the other ones. So inverse Trig derivatives, we did that yesterday. So this is again page 30, very back of your packet here. Implicit differentiation. I crossed it out, but I'm actually going to have it on the test. Very similar to what you guys did on the quiz, but I won't make a tangent equation. I'll just ask you to find the derivative. We'll do a couple of practice on that, but most of you guys did really well on the quiz, so that shouldn't be an issue. Just have to do a little bit of review. Related rates trig with the right triangle and starting with either sine, cosine, or tangents. We haven't done problems that were forced into quotient rule, so we'll have to still do some of that. Mean value theorem, trig derivatives, average rate of change. Average rate of change is just really a prerequisite for mean value theorem, right? Slope between the endpoints, that's all this is. And then the trig curve sketch problem, this is the one that is the biggest, the messiest part. We have to go through all that process, takes the longest. So we want to make sure that we can get through a couple of them over these next 4 days. Yeah, make sure we know our unit circle values, make sure we know our derivative rules for natural log of u and e to the u. Power rule, trig derivatives, inverse trig derivatives, I guess.
You said the particle motion is a bonus.
If I put it on the test, it'll be a bonus. I'm not gonna spend time on it.
Would there be like additional stuff that's like makes it harder to those a little bit more complex than the ones we've done?
Just because I haven't spent time going over it, I just that's why I
Okay.
I want to make it because I want to focus my attention on that. That's why. But yeah, any questions with your test topics here? We can tell that it's mainly going to focus on the new topics that we did after the quiz, but we still need quiz knowledge to be able to understand how to find the derivative and things like that. But there's, yeah, the one carryover from the quiz is your implicit differentiation problem.
So I can do the regular equations for quiz.
Right, but a lot of that is kind of built into the curve sketching problem, so we can know how to do that. So, okay, so remember the problem that we started yesterday, but we didn't finish? Let's go ahead and do that first, and then so page 11, I crossed out the 2x minus tangent x, and we started with the x minus 2 cosine x. Okay, we can also have our calculators out so that we can see the picture of our graph. So we gathered everything from the derivative sine line, right? Let's just also practice plugging this in our calculator. So we'll go to y equals. We'll type in x minus 2 cosine x. Make sure that you are in radian mode. I like to do zoom 6 just to kind of get that standard window going. But we're only concerned about from negative pi to pi. So you can do negative pi to pi as your x min x max. I'm going to say negative 4 to 4. Just so I can have a slightly larger window. But this is what we're trying to create. And the slope should match with our slope sine line. We have an increase followed by a decrease followed by an increase. So that's exactly what we're experiencing here. Increase, decrease, increase. Here's a way that you can double check your relative max. You know there's a relative max at negative 5 pi over 6. That's the x value, that's the y value. If I want to confirm that is the decimal value that I see in my calculator, I can do second trace, and I can look for a maximum. So second trace, option 4. So I'm going to make the calculator find that max for me. So I'm not going to find it myself. I'm going to make the calculator do it for me. So you see that left bound there? That left bound means I can pick a starting point for my graph to begin looking. So I want to pick a point below my relative max. Hit enter. And then it says right bound. So scroll over to a point on the other side of your relative max. I definitely want to put my cursor here. I'm going to put at a safe distance away. Hit enter again. And now you're gonna hit enter a third time. Now it's gonna get guess. You see those two arrows there? The calculator is ready to look for that relative max for you. Hit enter a third time. And then you're gonna get negative 2.6, comma, negative 0.885. And if you plug negative 5 power 6 into your calculator, that should get you a decimal of negative 2.61. If you plug this in the calculator, you're also going to get a decimal that will match that negative 0.885. So it's nice. The calculator is not absolutely necessary, but it just kind of gives you a safety net to kind of confirm that, okay, all this thing that you're doing, you can confirm to see whether you're on the right track or not. Likewise, you can repeat the same process. If you want to find a relative min, you will just do second trace and you will choose the minimum option. And then you'll pick points on either side of your relative min and make the calculator find it for you. Right. So definitely practice that feature. It's more of a helpful thing to do this semester, but next semester we need to be able to do it. It'll be something that we definitely need as part of solving a problem. But yeah, if you're stuck with anything with your calculator, be sure that to ask me either during class or after class. So I want you to feel comfortable with your calculator. Okay, all right, so let's keep going. We've gathered everything from the F prime side of things. Let's move on to F double prime, where we're going to find critical points, point of inflection, intervals of concavity, and then Y value of the points of inflection. So again, we're continuing on page 11, using that blank page to do a problem for our curve sketching. Okay, so F double prime. So F prime is 1 plus 2 sine X. What's F double prime going to be? Just what? 2 cosine X, right? That 1 is going to go to 0. And to find critical points, I set that equal to what? 0. Divide by 2. I'm just looking to see where is cosine equal to 0. So let's just think about values between 0 and 2 pi. Where is cosine equal to 0 at? Yeah, pi over 2, right? Pi over 2 and where else? Yeah, I'm going to say 3 pi over 2, but yes, we can find, because we ultimately have to fit these into our interval. And pi over 2 is safe, but 3 pi over 2 is slightly outside. So we're going to force that 3 pi over 2 into something that falls within range. So I can subtract 2 pi. Like you said, negative pi over 2. So we have pi over 2 and negative pi over 2. We'll go ahead and place them onto our second derivative sine line. All right, all the graphs I give you will be nice and alternating. Let's choose an easy one to test. So if I insert 0, where am I going to insert this into to test for concavity? Double prime. Okay, so 2 cosine of 0, what's that? Positive or negative? Therefore, concave up. So if this is concave up, then that's all I need, because I know my graph is going to alternate. Okay, I do want to give a disclaimer here that we don't always want to assume this is going to be the case outside of trig. Okay, just because I want to make things a little bit easier for us. So I'm telling you that your signs will always alternate, but when we do curve sketching in general, we don't want to just always assume this. We should be testing each of these because there could be repeated signs, right? So just to let you know, this is just to make the problem easier. Okay, I don't want us to think that this is always going to be the case for every curve sketching problem. Okay, so what can we expect then at these critical points? What can we call these points? Force inflection, right? And if I want to find the physical order pairs, put them back into the original. Okay, so here's the original. X minus 2 cosine x. We'll insert, evaluate at those points there. Okay, so if you don't recognize negative pi over 2, look back at where it came from. It came from 3 pi over 2. So what's cosine of 3 pi over 2? It's going to be what? It's 0, right? Okay. So that's going to wipe this whole thing out. I'm just left with negative pi over 2. So my order pair is simply negative pi over 2, comma, negative pi over 2. Into the original function, pi over 2 minus 2 cosine of pi over 2. That's going to be 0. That's going to go away. Okay, so we have our order pairs. Everything we need is almost, yeah, we almost have everything we need. The only thing left is finding the endpoints so that we can plot those points onto our graph. So let's also find the order pairs at the endpoint. So we'll find f of negative pi, we'll find f of pi, and then from there, all the most important points are in front of us, right? We have all of our relative max, relative min, points of inflection, plot all that on the graph, and we should connect the dots. Okay, I'm just finding the locations of the endpoints back to the original function. Cosine of negative pi, same thing as cosine of pi. Cosine of pi is -1. So I'm just going to estimate it. This is -3-ish plus 2. It's around -1. But you can also plug in the calculator as well. Cosine of pi is -1 again. So pi plus 2. Pi is around 3-ish. So 3 plus 2 is around 5. Right, just so I can have something to look at when I graph. So here's my f of x graph. So negative pi is around -3. Graph's going to start somewhere here. It's going to end up at 3, 5. Again, I'm looking at my graph here. It should resemble this when everything is said and done. Okay, we already tested that this is around like -0.8, and we know -5 pi over 6 is really close to -3, but a little bit less than -3, so like -2-ish. Okay, we know that there's a relative minimum, sorry, relative max. I'm sorry, relative minimum, my bad. -pi over 6 is slightly to the left of 0, and this is basically -3 over -1/2 minus 1. It's like -2-ish, -2, 3-ish. Okay, so we know our graph is going to kind of have this shape, or in terms of relative max, relative min. I'm looking at concavity yet. Just want to be able to sketch the graph. I know my points of inflection is at -pi over 2, -pi over 2. So that's that -1.5, -1.5. And then my other point of inflection is at 3/2, or 1.5, 1.5. I can exaggerate my concavity here, right? Concave down. My first point of inflection, then it turns into concave up. So concave down here, followed by concave up, followed by concave down. Not exactly, but it's enough for us to, right? It follows the shape of the graph. That's all we need. Okay.
But you say you're not gonna like look at the drawings too much, so they like resemble.
Right. Yeah. As long as it resembles your arrows and your concavity, that's really where, right? Because I mean, I know it's not going to look the same because our order pairs are not. The scale is different, right? Which is fine.
So you want to draw like a derivative graph or a concavity graph.
No, you're just going to draw the original function graph. Yeah, that's it. That's all you're going to do. I'm skipping all the where I think is the easiest parts. Naming the relative max, increase, decrease. Do we need to practice that? Do we think we're good? All right. So hopefully we feel good about all the because statements, right? Because really, that's the easiest part, right? You just naming all the intervals and all the because statements. So hopefully, I just want to get through I just want to walk through the hardest parts of the problem, so that you feel comfortable with them. All right, so you will see one problem like this. It'll be either sine or cosine. Yeah, very, very similar to this. So we've done 3 of these already. We'll probably do a couple more. So hopefully by Friday, we'll feel good for Monday.
Will you give us like a whole page to do this one?
Yeah. And again, if you ever feel like you need additional space, feel free to grab more scratch sheet. Yeah, I never want you to feel like you don't have enough room. Take as much room as you like. Okay, good. I think I want us to do more practice with inverse trig derivatives, and then tomorrow we'll do mean value theorem, related rates, right? So, but I think this is really what I really want to make sure I got through. So we didn't get a chance to do page 24. So why don't we do this? Why don't we review through the derivative rules and then have you guys try these rules again. So I would like for us to practice writing our derivative rules from scratch.
The inverse ones or
The inverse derivatives, right? Do you guys have room? I don't know where I asked you to put it. Do you guys have room on your calendar page at the bottom? The calendar is going to be on the inside cover of your first page.
we used that.
Oh, yes, you did. Sorry, you did use that already. My bad. What about page 1? Okay, so page 1, we didn't do number 1 and 2, right? So can we use that space?
We thought we did.
Sorry.
We don't want to answer.
Okay, yeah, number 2 or answer keys. Yeah, okay, wherever you find empty space. Even on maybe page 3 here, there's empty space here. Okay, so let me, before you guys write these down, let me run through the rules again, and then we'll try it. Okay, so again, we have arcsine, arctangent, and arcsecant. Those are the most important ones. We talked about how we want to start off listing out the parts that are all the same. Your numerator are all going to be the same, just u prime. The denominator, they all have 1 and u squared, right? The easiest looking one is arctangent. It's got the 1, the plus, the u squared. There's no absolute value. There's no square root. It just looks nice and clean. Next up is arcsecant. That's the most complicated looking one. I like to do this one next because that can help me remember where the u goes. I know there's a square root involved. I know there's a 1 and u squared, and I know there's a minus sign. That's what's different about it. But I know that the u squared is going to come first because the u's are next to each other. So that's how I remember where that order goes. And if I can figure out this order, then I know it's a slightly different order for my arc sign. It's the 1 minus. And if we can do this, then the other three are going to be pretty straightforward because we know we're just going to put a negative of the expression, the derivative rules that we see in front of us. All right, so let me erase this and have you guys try. And all the C functions are in alphabetical order. Just like how we did our trig rules. Okay, hopefully, if we didn't get them all right, we're making improvements from yesterday. Okay, so let's go to page 24. And we're just going to practice with finding derivatives for our trig. We're going to try through this worksheet. The key is on page 26. And some of these problems is just applying the rule as you see it. Others may require a product rule. Still others may require quotient rule, not quotient rule, chain rule. So go ahead and start off with 39. Check your progress with page 26. I'll walk through each of them, but I'll also see if you guys have any questions as you're trying these problems. Page 24.
We're on a review packet yet, we're still on the review.
Right, right. Well, yeah, I figured we'll just save the review for tomorrow. If you don't reduce your answer, it's fine.
Also, once it's u squared, it means the entire u function remains.
That's right. The entire u expression is squared. If you want to, yeah, some students were asking, can I resolve this? You could, but just don't do it the wrong way. You got to flow this out. I can't just say x squared minus 1 squared. That's, so
Oh, so it's like, well,
you got 4, but might as well just leave it in the simplify, right? Because that's already fine. But once you have 2.
they cause mistakes.
Right, yeah. Yeah, the less you simplify on the AP exam, the less room they have to take off points.
You sort of want to multiply it to the new one.
Yeah, so this is really 2 over 1, right? 2 over 1, so 2 goes down to the denominator. Okay, 46, what do we have to make sure we involve what? Powerful, yeah.
We simplify the, the ones. Simplify and split over the one plus one five and split.
It's tempting, right? Why can we not do that?
It should.
Yeah. That's getting away. But if the one wasn't there, then yeah, I can reduce it all I want, but. Yeah, we can't go any further.
Can I leave it in a 5x parenthesis too at the top, or you want me to like, is it fine if you don't make it 25 square?
Oh, yeah, that's fine. Yeah,
Or we can
this is
just leave it like
fine.
that?
That's fine. But this will be wrong. But if you did that, that'll be
Yeah.
wrong. Okay.
Gotcha.
Parentheses is fine. Okay, well, 47. What rule there? Okay, yeah. So there's outside, inside, but also just know that when I have you memorize all your trig rules, they all have chain rule built into it, right? That cosine of u times u prime, that is chain rule right here. So just keep in mind that when I have you memorize those rules, they're all are chain rule built in. So you just think that, oh, I'm just applying the rule for sine, and that's fine as well, because that u prime is taking care of the inside portions through it. So for these chain rule, I may ask you to get the answer down to an algebraic expression. And that would require you to have some knowledge with the triangle. So there's two ways to look at it. One is that cosine and arc cosine are just inverses of each other. They're just going to cancel each other out. I'm just left with t. Another way to think about it is that cosine of arc cosine of t, this is basically theta, right? So kind of work through that process. Theta is arc cosine of t. I can move that cosine over. Cosine of theta is equal to t. I can force a 1 in the denominator. Draw my triangle. Cosine of theta, it is adjacent over hypotenuse. Pythagorean theorem. 1 minus t squared. And now I can turn around and say, what is the cosine of theta? Still what? T over 1, right? Still t. So I can look at it from that perspective as well. Yeah.
Sure, we can't leave it like we can't leave it in cos arc cos.
Right. So This one you can, this one you can't. So what I will say that on the test, if I want you to go further, I will have to ask you for it. I would say, leave your answer in algebraic expression form, but that means no trig in the final answer. You gotta get it all the way down to X's or T's. Okay, number 50, there's a little bit of review, some older rules there. Natural log of u is u prime over u. And then the second term is just arctangent rule. Okay, try that first and I'll go over with you. And this one, you don't have to clean up the fractions. You can leave them unsimplified, that's fine. Sometimes t over 2 feels like it can be easier to read if I write it as 1/2 t, right? That makes it easier to see, oh, that's just power rule, 1/2 t becomes 1/2.
Those are using, go back to log functions.
Mhm.
Going back to log functions.
Right, so moving forward, the most important derivative rules are going to be power rule, natural log, and e to the u. Those are the most common ones. I'm going to keep bringing those back. So there are more obscure rules like we saw with log base b and log base a and a to the u. Those are not as common, but I'm going to keep bringing back natural log and e to the u. I don't want us to forget those.
So we keep building on what we already did.
Yeah, but we've learned all our derivative rules. All the derivative rules are done. Next semester, we'll do integral rules. But the nice thing about integral rules is we're just working backwards from the derivative rules. So
Antiderivatives.
yeah, antiderivatives, exactly. So I mean, it's still going to be a learning process, but it's nice to kind of have a foundation of derivatives, knowing that we already know these. We just have to kind of undo them.
The process will be easier.
It'll be a good building block for us. Yeah, I mean, learning antiderivatives without knowing derivatives in the first place will be a lot harder. Okay, any questions? Okay, so we got through, we did some more practice with inverse trig derivatives. That's good. We did a full, we finished a full curve sketching problem. So really, I'm just going to focus my attention tomorrow on related rates and mean value theorem. We haven't done those in a while, so we will get to those. And then we still have Thursday and Friday to go through the test review and just keep picking out problems and getting more comfortable with everything. All right, come get your phones. Yeah, so there are lots here. Go up there and highlight those. I mean, they're. I don't know. It's one of the large.
We're done. What do you think? Oh, right. No, all over. You're all. Yeah, we were. On the was the first day we were. Oh, that's. Yeah.
Guys, if you have any calculator questions, make sure you ask it so that I want you to feel comfortable with it.
Oh,
with that.
Yeah. What's from this season?
Why did you put 4 in front instead of 2? If it's like
It's
this.
unit.
Where'd you get?
Yeah, so basically what I did, I had this one half.
It's probably pretty easy.
Oh yeah, here's 1/2 times 1/2 versions are right. So I'm just pulling that 1/2 out in front. If I can just pull that out, so this is 1/2 times 1/2 times 1/1 squared. Nice to make that one. I can always pull it, the numerator, and just make it a separate
And
problem.
if I didn't do that,
That's fine.
like, I don't know what I did. I did like, it just wasn't as simple as that.
That's fine. Because, you know, I did common denominator here. That's why I got to this point, but you can leave this. Very good. Even those here. How are you? You good?
Yeah. That's what we, next we have this is gonna be, is that like a economics test?
Oh, you. Yeah. But I think, any administration try to spread things out so that not all of us are on the same day. So.
But you guys have,
the 70 or whatever.
I said Trevor Howard.
Yeah, hopefully manage on your.
Yeah. That's the. Oh, well.
And that way, hopefully you don't have to do any recoveries like next week. Monday through Friday will be free for you.
You might come in early, like later this week to do something.
Sure, yeah, you can recover anything, even if it's.
Okay. Yeah, I understand this stuff.
Yeah, I mean, you did pretty well on the quiz, so you just kind of feel
Okay.
off that knowledge, right? So.
Oh, did you grade it, please?
I did, yeah, it should be in the grade book, but I'll hand it back to you tomorrow.
I felt like I didn't go in like with the trig values, but I just like tried simplifying it, and that's where I got wrong.
Yeah, I think that is an issue where you just left it alone and they have. Better. But it's good to learn when you can simplify and when you can, and you know, what you can't do with simplifying. To know those things too.
How much are you marking out for?
Pretty minor. If you have the right answer and you made a mistake, that's just like 1 or 2.
Okay.
That's last.
Okay.
So the Bills gonna be 11 seed now. We get the Bengals one.
How are the Bengals winning?
I don't know. Make sure that's expected. Remember Lawrence went out for the year. So maybe.
But then,
I think what they will overall.
yeah, it's.
And quarterback and receivers are the most
Yeah.
difficult position.
Yeah.
You're always getting hit.
Injuries have been terrible this year. In to replace being just have Brad's perfect.
Yeah.
It's terrible.
And Rogers maybe covers that anything.
Yeah. But it's like, I don't know if it's working though for them. Because, you know, their season's pretty much
Yeah,
over.
it's good for morale that you can have some good games to end the season.
If you had the Justin Fields.
Yeah, I don't know. There's,
I think he's trying to draft my quarterback.
but there's 2 good quarterbacks. No, there's so many
You
quarterbacks.
have 2 top 10 picks, I think.
Yeah, I feel most likely.
Well, that's.
I get a new coach too, I mean, maybe, I don't know.
Just switch everything out.
Stick.
Yeah.
Yeah, play at Kansas City and win after they lost.
But it wouldn't be nice though to hand them 2 losses in a row.
Yeah, but like that. They don't, like, the thing is like I didn't want to, I was rooting for them to lose against Green Bay, but like at the same time, I was kind of worried because I know they play really well coming off the loss. So they don't win. Like, I just thought we're arrested, so hopefully we come back with confidence.
It used to be the game that everyone wanted to watch, right?
Yeah.
Bills versus Chiefs. That's what everyone wanted to watch.
It's still a good game.
Still, that's gonna be
We
good.
have to win it though.
Yeah.
No, honestly, like this.
We put ourselves in a situation where we can't get to win out.
Yeah.
It's gonna be tough.
Well, hopefully having an extra week to rest and prepare will be good.
Yeah, because they're gonna play the Cowboys at home after
I was at home.
at the Chargers, which,
That's doable.
yeah, we definitely need to win that one. And then home against Patriots.
You can do that one too.
At Dolphins. That'll be tough.
Be tough.
Which like I might be going to the Bills Patriots game about